Exercise A08 is really similar to exercise A01 insofar that it's involving a counter controlled loop, okay, a counter-based loop, and it's going to do what we did with one single loop in exercise A01 with two nested iterative statements. Okay, the purpose is we want to write a program which is going to use nested loops, of course, to display the multiplication tables from 1 to 9. So for each number between 1 and 9, do what? Display a multiplication table. How do you display a multiplication table? Well, you take this number, 1 at the first iteration, 2 at the second, 3 at the third, etc. And you multiply it by what? By every number between 1 and 9. So this is where the double nested loops come into consideration, okay? So before even to get started writing code, let's figure this out, okay? You want to do something such as for, let's call it number n, okay? For n between 1 and 9, do what? And I'm using a very relaxed form of pseudocode here. Well, inside of each, I'm going to have an over 4 for x equal 1 to 9. Do what again? Display. And I'm going to use a Raptor syntax here. Display the value of n followed by the string times followed by the string x followed by the string equal followed by the result of computing n times x. And that's it. That's what we want to display. So this is a very, very simple structure. What is very important to understand is to realize that this is a structure, this is a problem that calls for two nested loops. Okay, for each number between 1 to 9, then for each number between 1 to 9 again, multiply the two numbers together and display the result on the screen. So we are going to move on and implement this immediately using Raptor. So let's start by the structure of the code. A first loop. Okay, what is this loop going to do? It's a counter-based loop, so I need to initialize, assignment, I need to initialize a variable. Okay, I'm going to call this variable, let's call it n1, number 1, and I initialize it to 1. I enter my loop, and I'm going to do some work. The work I need to do is actually another loop, which is going to multiply the value of n1 by every number between 1 and 9 and display the result on the screen. So here, right here, there's going to be some work to be done. Okay, I'm leaving this blank for now. Then my condition will be when n1 is greater strict than 9, I exit my loop. Otherwise, I go back and I keep working. So I have my first structure. Now here, I left this blank. I'm going to refine, okay? What do I need to do really here? I need to insert another loop. So I have two loops inside one another. The first one manipulates n1. Start with n1 equal to 1, keep looping, and I forgot to introduce here when I was going to increment n1. Well, let's do it right now, okay? I have n1 equal to 1, I do my job, I test if I need to exit, and then I'm going to increment n1 as the last step of my loop. So set n1 to the value n1 plus 1. Now, going back to my inner loop, my inner loop here is going to do a similar job with a variable n2. So I start right before my inner loop. I start by initializing the variable n2 to the value 1. Then I get inside of my loop, okay, and I'm going to here display the result of n1 multiplied by n2. So I'm going to output an expression, and I'm going to say value of n1 concatenated to the string star, concatenated to n2, concatenated to the string equal, concatenated to the result of multiplying n1 by n2. Done. So that's my main outcome. Okay, I display here the result of n1 times n2. Once I'm done, I'm going to test. I'm going to test if n2 is greater than 9, then I get out of my loop. And getting out of my loop means going and branching back inside of the outer loop right before its test. Okay? And if I don't get out of my loop, then I'm going to use an assignment here. And I'm going to say that N2 is now N2 plus 1. It's really important that you take the time to review this code and really understand how it is composed of two loops nested into one another. Okay, and there are going to be practice exercises to help you rehearse this kind of skill anyway. Okay, so we'll have more exercise with nested loop pretty much, but you need to understand right away how there is one loop inside of another loop inside of this flowchart diagram. Well, let's give it a test. Let's give it a shot right now and try to figure out if this is working. And if it's not working, that will give us feedback to go back to our code and examine exactly where we went wrong. Okay, so I'm going to start execution of this code. Loop 1, loop 2, display something, increment n2 is equal to 3, 4. You see that we are inside of the inner loop. So we keep iterating inside the inner loop until what? Until n2 reach the value 9. Okay? But so far n1 is still in its first iteration and n2 keeps increasing. N2 reach 10. We got out of the first inner loop and we are in our second iteration for the outer loop. We reset n1 to 1 and we start counting again. So I'm going to speed up execution here to let this program do its entire job. Okay, display the entire multiplication table. So this is going to take a little while. We are going to let it work. When you are testing programs like that, you can refrain them from going the full length. Okay, for example, display only the multiplication table for 1 to 5 or 1 to 3 only. Okay, but okay, we have our full version of the program here. Now let's figure out if it worked. This is the output as it was displayed. I'm going to scroll back up. This is a table for 1. 1 times 1, 1 times 2, 3, 4, 5, 6, 7, 8, 9. This is correct. And then here I went 1 to 4. Okay, it's actually okay for a multiplication table to go from 1 to 10. Okay, no problem. We could even have started at 0 to 10. If it's not the intent of my exercise, however, that means that I just need to correct something here so that I don't go 1 to 4. Then we do the table for 2. Start by multiplying by 1, go to 10. Okay, that's fine. 3, 4, 5, 6, 7, 8, 9, everything works, and I'm doing here the multiplication table for 10. So let me check back real quick. Well, okay, the way that this was formulated here is ambiguous because I'm saying display the multiplication table from 1 to 9, and then this output omitted here could indicate that we go further. No, we go and finish the table of multiplication for 9. So we are going to fix that in the program. We're going to modify our program so that it it shows the multiplication table from 1 to 9, and inside of each table it multiplies the number by 1 to 9 only. So what is happening here? Initialization in both loops starts at 1. That doesn't seem to be a problem. Okay, I keep increasing my number after I have displayed the result. So let's focus here for a moment on the inner loop. Okay, what is happening? When I enter this loop, let's say that n1 is equal to 1. I enter this inner loop here. n2 is assigned to 1. Then I display on the screen n1, which is 1, times n2, which is 1, equal, and the result of the product. Okay? Then I test, is n2 greater strict than 9? No. I go back here and I increase n2 by 1. When I come back to the beginning of my loop, I will now display 1 times 2 equal 2. And I will keep iterating like that. Okay? n2 is not greater strict than 9. I increment it. n2 will be 3, then 4, then 5, then 6, 7, 8, and 9. When I reach n2 equal 9, I display here 1 times 9 equal 9. Then I check, is it greater strict than 9? No. I increment by 1. I increment by 1, so now N2 is 10. And I go back to the beginning of my loop and I display 1 times 10 equal 10. So I went 1 to 4. Why? Because I increment after testing. So I'm going to try to rectify the situation. Okay, let me erase the inks here real quick. I'm going to try to modify the order of my testing and the order of my conditional of my testing and my incrementation. Okay, in order to detect earlier when I reach 9 and get out of this loop. Okay, so here we go. I'm almost done erasing all of this. I'm going to take this assignment here. I'm going to move it one step ahead. And apparently I grabbed more than I was asking for. So I'm going to do this again. I'm going to just take this assignment here and I'm going to move it one step ahead before the conditional test. This is my new modified program. Only the inner loop has been modified and I'm going to test it again. In order to make the test a little faster, I am going to modify the condition of my outer loop, which is here. And I'm going to modify it so that we don't display all the multiplication table between 1 and 9, but just between 1 and 3. Okay? Let me try again to execute this code. And let's have a look at the result. Multiplication table for 1 between 1 and 9. Bingo! That fixed the problem. Now I ask for my multiplication table for 1, 2, and 3 to be displayed, and I go up to multiplication table for 4. So I'm still 1 to 4, but this time it has nothing to do with the inner loop, it has to do with the outer loop. So most likely I have the same problem in the outer loop than I had in the inner loop. So I'm going to keep this number 3 so that it speeds up my test, okay, for now. And I'm going to think about my outer loop. One good way to be able to think about the outer loop is to try to keep the inner loop out of the picture. I clicked on it, it appears in red. Well, let's try to think about the program by assuming that the inner loop in red is like a black box. We know it's working, so let's ignore it, put it out of our mind, and focus on the outer loop. Outer loop starts here. Before it, N1 is assigned to 1. I don't seem to have a curl with that, so I'm going to keep it. Then all of this here and here is my inner loop at work. At test, is N1 greater than, well, it should be 9, but for the sake of speeding up my test, it's 3. Is it greater than 3? Well, at my first iteration, N1 is 1. I do the job, and I test. Well, I'm going to try to apply the same fix here than I did for my inner loop. I'm going to first increment N1 and then test it. Let's give it a try. Bingo. Every multiplication table goes from 1 to 9, and if I said that the maximum number is 3, then we stop indeed at 3. So now I can, once again, just to be on the safe side, I can go back to my code and modify again this condition, and instead of making a quick shortcut to 3, I can go back to the value 9, and I can run my code in accelerated speed just to make sure that all the multiplication table are displayed. And I'm going to minimize this over window since we're like at this point mainly interested only in the final result. And there we go. The multiplication table go up to 9. Inside of each multiplication table we go from 1 to 9. So this is correct. So even though it would have been acceptable to start at 0, to go up to 10, etc., the idea of the exercise is not only to make a program that is acceptable. The idea is to give you some specification about a program and to teach you how to respect the specification to the letter, okay, and learn how to adjust and correct your program accordingly.